When we think about the world's greatest scientists, we immediately think of Sir Isaac Newton, Henry Ford, the Wright brothers, Thomas Edison, and Albert Einstein. Aside from that, there is a name that few people remember. But we have heard his name enough in this viral world. Many of his innovations may be in use without you even realizing it. For example, every time you turn on a light, use a generator or freezer or charge your phone, you should thank a scientist. He is the genius, Nikola Tesla. Many of Nikola Tesla's innovations continue to be widely used today. The most significant of his innovations was AC or alternating current. He dreamed of providing wireless electricity to the entire world 100 years ago. This video will mainly focus on some of the Nikola Tesla's inventions of AC and DC and 369 of these topics. Everyone is aware of the conflict between Nikola Tesla and Thomas Edison. Nikola Tesla preferred alternating current, but Thomas Edison preferred direct current. The conflict between the two over AC and DC was ultimately won by Nikola Tesla. To understand why AC won between AC and DC current, we must first understand what current actually is. Simply put, current or electricity is the movement of electrons. Imagine if you had somehow separated some electrons from just this place and brought them to this place, so that the number of electrons here would be higher than normal. As a result, this side will be negatively charged, and since electrons have been removed from this side, there will be deficit of electrons, thus this side will be positively charged. Now that you have created a difference in charge between the two places, it is called a potential difference. Now, if you connect these two places with a conductive wire, the extra electrons from the negative end will start moving toward the positive end and try to create an equilibrium state. This will create movement of electrons, and this matter is called electric current. Creating a gap of charge between two places can generate electricity, and you will get powers as long as you can maintain this charge interval. There are two types of current based on the movement of electrons: direct current and alternating current. Consider a battery with this end being positive and this end being negative. Now, if you connect the two ends of the battery, the excess electrons from the negative end will start moving towards the positive end. Here, the movement of electrons is unidirectional, i.e. from negative to positive end, and the current generated due to unidirectional movement of electrons is called direct current. The potential difference of the battery will decrease with time, and when the potential difference becomes zero, the battery will become ineffective. That means the charge gap between the two ends will become zero. One thing needs to be mentioned here, as we know that electricity flows in the opposite directions to which electrons flow, but this information is not correct. When electricity was discovered, people did not know much about electrons, so people thought that electricity would flow from a positive to a negative direction. The current flows in the direction in which the electrons flow, i.e. from negative to positive. Whether the direction of electricity flow is positive to negative or negative to positive, there is no effect on the final mathematical result. However, the basic concept of current flow is still retained. Anyway, let's talk about alternating current. In alternating current, electrons change direction repeatedly. Once this way, then that way, again that way. And how many times per second it changes direction, it's called frequency. The electricity we use at home changes direction 50 to 60 times a second. It does not mean that the electrons come from positive to negative, because the source from which the current is sent is constantly changing between positive and negative. As a result, the direction of the current changes continuously. However, due to the change in the direction of the electron, the voltage of the electronic device also increases. If you do a slow motion video of a light bulb, you will see fluctuations in the brightness of the light bulb that are not normally visible, because these events happen so fast that our eyes cannot catch them. However, let us now see why AC became popular as opposite to DC. We know that in the case of electricity, power equal to electric current into potential difference. That is, if you send electricity from one place to another place through the wire, how much output will be obtained depends on I and V. Note here that you can get the same amount of power by increasing the value of I and decreasing the value of V. Now any conductor which sends electricity from one place to another through a wire will have its resistance. And because of that own resistance of the wire, some of the electricity is converted into heat energy, thereby wasting electricity. Now the question for heat loss in the wire is heat loss is equal to I square into R. Here I is the current flow and R is their resistance. So note that the higher the value of the current, the higher the power loss. As a result, it was necessary to reduce the power loss by reducing the value of the current flow. Now P equal to IV is in the equation. If we decrease the value of I and increase the value of V, the same amount of power output can be obtained. And this is why AC was ahead of DC. In the case of AC, it is relatively easy to increase the voltage by decreasing the current. This can be done using a transformer, which is not possible in the case of DC. Therefore, a large amount of electricity was wasted in the transmission of DC from one place to another. AC was much cheaper to send over long distances than DC, and AC could be easily converted from high voltage to low voltage and from low voltage to high voltage. This is why AC eventually became popular and is still used to transmit electricity from one place to another. At present, electricity from the power station is sent through low current flow and high voltage. And in the case of sending that high voltage current to our homes, it is again brought down to low voltage through a transformer, and that voltage is approximately 220 volts to 200 volts. However, this is nothing to be underestimated. All the portable devices we use, such as mobile, laptops and cameras, but this is used. You must notice that there is an adapter in the mobile charger. The main function of this adapter is to convert AC to DC. Also, in many other areas, Tesla showed extraordinary talent. He was the first to control a boat using radio waves without touch, which was the world's first remote control device. He invented the first neon light. Tesla was also working on X-rays at the time of Rontgen's discovery of X-rays in 1895. Although Rontgen published his research before Tesla, later Tesla developed his own technique to producing X-ray through vacuum tubes, which he called shadowgraphs. The shadowgraphs played an important role in improving X-ray technology, and Tesla was the first person in America to capture an X-ray picture. This also happened with Tesla in the invention of the radio. Tesla was also working on radio at the time as Marconi. However, due to some accident in Tesla's lab at the time, Marconi finally published his research before Tesla. Tesla also has many other inventions. Nikola Tesla was a very talented man. He didn't just think about contemporary issues, he thought far-reaching. Part of this far-reaching vision is to provide wireless power to the entire world. Keeping this dream in mind, Tesla invented the Tesla Coil. With this Tesla Coil, Tesla showed that wireless power transmission was possible. If we apply AC current to the Tesla Coil, an electromagnetic field is created around the Tesla Coil. Now as AC is applied, the electromagnetic field changes direction repeatedly. This alternating electromagnetic field makes any electronic device near the Tesla Coil attractive. As you can see, when this light is brought near the Tesla Coil, the light turns on, and when the light is moved away, the light turns off. Tesla Coil is usually given a high current, which is transferred to high voltage and creates an electromagnetic field in the vicinity. Tesla installed this huge Tesla Coil to realize his dream and planned to install such towers in other parts of the world. Through this, he thought it would be possible to supply electricity to any electronic device without wires. However, this wireless system is not practical because it cannot deliver power over long distances. But currently, we are seeing this wireless technology more and more in short distances. We see this with wireless charging pads, which use a similar principle to Tesla coils, even though they work a bit differently. However, many things can be said about Nikola Tesla, but now let's talk about the 369 topic. Although Nikola Tesla was a very brilliant man, he has been quite controversial for his various actions and words. One of them is probably 369. He thought that if he understood the glory of the number 369, the universe would be known. That is, this 369 is the universal code. According to him, communication is possible with a creature from other planet or with a supernatural medium based on or applying this number. He was so fascinated with these numbers that he tried to maintain them throughout his life. and he spent the last days of his life in a hotel room numbered 3327. However, these numbers can be distinguished by certain characteristics. You keep on doubling it with 1. Now if you add the digits of each number you get from doubling, you get 124875, a pattern where 369 are missing. Again, you keep having it continuously with 1. As a result, if you add the sum of the numbers, you get 157842. One such pattern is missing 369. Now you consider the number 3 and keep doubling it continuously. Adding the digits of the numbers, you get a result. You get 3 and 6. Now you keep having 3. Adding the digits of the numbers you get as a result will give you a pattern of 3 and 6. Now you consider 9. Keep doubling 9 repeatedly, and adding the digits of the resulting numbers will give him 9. Again, keep halving 9, the sum of the resulting numbers will be 9. Also, different analysis of these numbers 3, 6 and 9 can be done from different aspects. Because of all these things, Nikola Tesla considered 3, 6, 9 special numbers. However, I am not sure that all the patterns I mentioned here were invented by Nikola Tesla himself or by someone else later. You can analyze any number by considering it from different angles. So many argue that we have no justification for finding such similarities and reconciling them with science. Such number matches can be called philosophy rather than science. But I have some faith in the compatibility of many things with the patterns of numbers. Dear friends, if you want to know about some telescopes under construction, you can watch this video. If you like the video, you can subscribe to our channel.